Hi students, welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic today chosen is from chapter 11, Dual Nature of Radiation and Matter. Already 7 questions we have floated in the previous session. That's 7 questions. We are going to solve the problem for those 7 questions. Let's move to question number first. Light of frequency 1.5 times the threshold frequency is incident on a photosensitive material. What will be the photoelectric current if the frequency is off and the intensity is doubled? That is, light of frequency 1.5 times of threshold frequency. Threshold frequency denoted by a symbol nu naught. And nu equal to frequency nu equal to 1.5 times of nu naught. 1.5 times of nu naught. What is nu naught? Nu naught is the threshold frequency. And what will be the photoelectric current if the frequency is off? That is nu equal to, that is a nu dash equal to nu by 2. And intensity is doubled. Intensity may be I dash equal to 2 times of that intensity. And emission of photocurrent, photoelectrons, does not depend upon intensity here, and it depends upon threshold frequency only. What is threshold frequency? Threshold frequency is a minimum frequency in which photoelectrons will occur or photoelectric current will occur or flow. And if nu dash equal to nu by 2 means, then nu dash equal to, as it is given, 1.5 by 2 of nu naught. That is equal to 1.5 by 2 is 0.75. 0.75 nu naught. That is your, what will happen? Now this frequency is less than nu naught. That is nu dash is less than nu naught. And there is a very important condition for photoelectric effect. That is, frequency must be equal to or greater than threshold frequency. Then only photoelectrons will emit or there will be a flow of photoelectric current. So as it is less than this, there is no photoelectric current, no photoelectronic emission or no photoelectric current. Therefore, it is 0. That is option. Let's move to second question. Photons with energy 5 eV are incident on a cathode C in a photoelectric cell. The maximum energy of emitted photoelectrons is 2 eV. When photons of energy 6 eV are incident on C, no photoelectrons will reach the anode A. If the stopping potential of A relative to C is dash. Here, formula is energy is equal to, energy of the photons equal to kinetic energy maximum, maximum kinetic energy of electron plus phi. What is phi? Phi is a work function. And photons with energy 5 eV, eV is 5 eV given, and you want to find phi only, stopping potential we want to find. Before that, find work function. Phi equal to E equal to kinetic energy max plus phi, then phi equal to E minus Ke max. Then E is given 5 eV. E equal to 5 eV minus kinetic energy maximum is 2 eV minus 2 eV. 5 minus 2, 3 eV. So that is your phi. Then what's the question? No photoelectron will reach the anode A if the stopping potential of A relative to C. You want to find the stopping potential of A relative to C. What is A and C? C is a cathode and A is the anode. And we know electrons will move from cathode to anode. So the stopping potential, this is equal to 3 eV is nothing but potential of cathode, difference of potential of anode. That is only equal to 3 electron volt means 3 volts. Then question is stopping potential of A relative to C. So V anode minus cathode. V anode minus V cathode equal to minus 3V. Minus 3V. That is option D. Option D is the correct answer. Let's move to question number 3. Light of wavelength 500 nanometer is incident on a metal with work function 2.28 eV. The de Broglie wavelength of the emitted electron is dash. Formula is lambda minimum, that is equal to 12.27 divided by square root of kinetic energy maximum. Okay, then 12.27 by square root of kinetic energy maximum. For this, first you want to find E equal to hc by lambda. Here data given is lambda is given 500 nanometer. 500 nanometer convert into meter, that is into 10 power minus 9. And H Planck's constant, 6.6 into 10 power minus 34. C, velocity of electromagnetic radiation, 3 into 10 power 8. Lambda is given. Substitute this here. This is equal to H is 6.6 into 10 power minus 34 into C, 3 into 10 power 8 divided by lambda 500 into 10 power minus 9. And answer we are getting is in joules. But work function, everything is given in EV, and also lambda minimum there, kinetic energy maximum, it will be in EV. It must be in EV. So convert this into EV. And also a lambda minimum equal 12.27 angstrom. Then, so if you want to convert joules into EV, divided by 1.6 into 1.6 into 10 power minus 19. Then simplify this. That is 1.6 this. 3 by 1.5 means 2. 3 by 1.6 means maybe 1.9 something. And 500 if you simplify means use 5 table, then 100, and here 5 3 15, 5 8 40, 0.38. And simplify this. We will get 2.48 EV. 2.48 EV. Okay. Then we know already the formula. From that formula, if you simplify means, then kinetic energy maximum. Kinetic energy maximum is equal to energy 2.48 minus 2.28, that is a phi is given, that is work function, phi is given 2.28 eV minus 2.28. Simplify this, what we will get? 0.2 eV. Substitute this here in lambda minimum. Lambda minimum equal to 12.27 angstrom, that is 10 power minus 10 divided by square root of 0.2. Then we will get here, if you simplify this, 27.4 into 10 power minus 10. And answer is given in 10 power minus 9. So bring it in 10 power minus 9 means, then this is equal to 2.74 into 10 power minus 9. 10 power minus 9. Unit is meter. This is lambda minimum. So lambda minimum, wavelength of the de Broglie wavelength, the emitted electron will be greater than or equal to 2.8 into 10 power minus 9. If you write this approximately, it will be 2.8 into 10 power minus 9. So option C is the correct answer. Okay, next question number 4. For photoelectric emission from certain metal, the cutoff frequency is N. If radiation of frequency 2n, 2 times of n, impinges on the metal plate, the maximum possible velocity of the emitted electron will be dash. Given here, m is the mass of the electron, and h we know, h is a Planck's constant, nu is given frequency. And so what you want to find? You want to find maximum possible velocity, V max. If we know kinetic energy equal to kinetic energy of mv square max, kinetic energy max equal to of m v max square, that is equal to h into nu. Here we want to find v max only. So from this v max square equal to v max square equal to 2h nu by this m comes down. Then Vmax equal to square root of 2h nu by m. Square root of 2h nu by m, that is option C. Option C is the correct answer. Let's move to question number 5. Photoelectric emission occurs only when the incident light has more than a certain minimum dash. Already we know photoelectric emission will occur only when the frequency is equal to or greater than frequency called threshold frequency. So here frequency only plays a role. Therefore, that is a nu must be greater than or equal to nu naught. Nu is the incident frequency and nu naught is the threshold frequency. Therefore, a frequency only playing a vital role. So, option C, frequency is the correct answer. Let's move to question number 6. In photoelectric emission process from a metal of work function 1.8 eV, the kinetic energy of most energetic electron is 0.5 eV. The corresponding stopping potential is dash. What's the answer? Yes, option B, 0.5 volt is the correct answer. That is kinetic energy. Kinetic energy equal to 0.5 eV. We know kinetic energy equal to eV naught. Kinetic energy equal to eV naught. V naught is the stopping potential. Then eV naught equal to 0.5 eV. Then what you want to do? You want to convert this into joules. eV to joules divided by 1.6 or into 1.6. Yes, into 1.6 into 10 power minus 19. And E, what's the value of this E? This is the magnitude of the charge, that also 1.6 into 10 power minus 19. So that things will be getting cancelled. Directly we can write as V naught equal to 0.5 volts. Just by removing EV, volt, replaced by volt. So what's the answer? Option B. Option B is the correct answer. Let's move to last question. Question number 7. A source S1 is producing 10 power 15 photons per second of wavelength 5000 angstrom. Another source S2 is producing 1.02 into 10 power 15 photons per second of wavelength 5100 angstrom. Then power of S2 and divided by power of S1 is equal to dash. You should find the ratio of power of S2 and power of S1. What's the formula? We know formula already. P equal to, that is E equal to H nu. That is the basic formula. E equal to H nu. Nu equal to C by lambda. Then H C by lambda. And power equal to energy by time. Time is 1 second, unit time. Then this is equal to power. Then power equal to Hc by lambda. And this is for one photon. If n number of photon means nh nu or nhc. So here nh nu or nhc by lambda. So power P equal to nhc by lambda. And here two cases are there. One is 10 power 15 photons per second for wavelength 5000 angstrom. Another one 5100 angstrom for 1.02 into 10 power 15 photons. So Hc will be maintained constant. So by removing the constant, P1 is proportional to N1 by lambda 1. Similarly, P2 is proportional to N2 by lambda 2. And here we want to find P2 by P1 or P1 by P2. Is it P1 by P2? No. P2 by P1 because power of S2 and power of S1. Therefore, P2 by P1. P2 by P1 equal to. Proportionality will be removed and we can use equal. Then this is equal to P2 by P1 equal to N2 by lambda 2 into N1 divided by lambda 1. It goes up as like this. Okay. And N2 is given. What's the value of N2? 1.02 into 10 power 15. 1.02 into 10 power 15 into lambda 1. What's the value of lambda 1? 5000 Armstrong. Convert into meter into 10 power minus 10. 5000 into 10 power minus 10 divided by lambda 2. What's the value of lambda 2? 5100 Armstrong into 10 power minus 10 into N1. What's the value of N1? 10 power 15. 10 power 15, 10 power 15 getting cancelled. 10 power minus 10, 10 power minus 10 getting cancelled. And these two 0 getting cancelled. And use 5 table, 5, 10, 50. And here 5, 10, 50.2. Then 1.02 into 10. 1.02 into 10, 10.2 by, in denominator, 10.2. So 10.2, 10.2 getting cancelled is equal to 1. Exactly 1. No approximation, no 1.0012 like that. It's exactly 1.0. That is option A. Option A is the correct answer. Okay. So today's session over. In next session, we are going to give 7 problems in the next chapter that will be floated in the YouTube. And next session, we will find the solution of that